Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer B, well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So X and Y are two radioactive nuclides. X has a half-life of 3 minutes, and Y has a half-life of 9 minutes. Two freshly prepared samples of X and Y start decaying at the same time. After 18 minutes, the number of radioactive nuclei in both samples is the same. The sample of Y initially contained N radioactive nuclei. What was the initial number of radioactive nuclei in sample X? So when I'm dealing with nice sort of simple questions about half-life, I quite often like to draw a little table showing how the number of particles changes with the number of half-lives. So I'm initially going to look at sample Y. And we know Y has a half-life of 9 minutes, and we might be interested to find out how many particles it contains after 18 minutes. Well, half-life of 9 minutes, after 18 minutes, 2 half-lives will have passed. So the table I'll produce, I always have half-lives on top and number of nuclei on the bottom row. Now for Y, I only need to go up from 0, starting point, to 1, 2 half-lives. And we're told the sample of Y initially contained N radioactive nuclei. So at the starting point, there's N nuclei. After 1 half-life, that number will halve, and after 2 half-lives, that number will halve again. Now we're told after 18 minutes, X and Y both have the same number of nuclei. So we know that X, after 18 minutes, also has N over 4 nuclei. But X has a half-life of 3 minutes, so after 18 minutes, 6 half-lives will have occurred. So I'm going to draw the same table for X, but this time I need to make the number of half-lives go up to 6. So 0 half-lives, 1 half-life, 2, 3, 4, and 5 half-lives. Oh, sorry, 6 half-lives. So after 6 half-lives, which is 18 minutes for X, X contains the same number of nuclei as Y does after 2 half-lives, which is also 18 minutes. So I can say that X, after 6 half-lives, has N over 4 nuclei. Well, after 5 half-lives, that number is going to be double the amount, which is N over 2. After 4, it's going to double again, and double again, and double again, and double again, and double again. And I'm doubling, of course, because I'm going back in time. If I was going forward in time, I'd be halving each time. But I'm going back in time because I want to find out the initial number of nuclei that X contains, and that's 16N. Well, I hope you found this approach useful. If you did, press the like button, comment below please, and I hope you'll share this video and watch more of them in the series.